Hi, I'm Glenn Thacker, and today I built a project to show the use of a 555 timer chip. So right now I'm using a 220 microfarad 10 volt capacitor to get the light to flash at this rate. I've experimented with some other ones. When I switch it out for a 100 microfarad at 25 volts, it gets a faster blinking like this. If I remove the capacitor, the light just stays lit because there's no capacitance.
Where's your ball?
So this is an example of a astable circuit using a 555 timer. Pin 1 is my ground. Pin 2 is my trigger, which connects my 100 microfarad capacitor to the ground. Pin 3 is the output, and that goes through a 1K resistor to the load, which is a LED, a light emitting diode. And the resistor is pretty much just there to keep the light from burning out. Pin 4 is the reset, and that's jumped back to pin 8 or the positive input. Pin 5 would be the control voltage if it were in use in this circuit, but we bypass that. And pins 6 and 7 are my threshold and my discharge. There are two resistors of 5.1K ohms between pins 6 and 7, and then 7 and 8, which would be the VCC. Pin 2, the trigger pin, turns on the output when the voltage supplied is dropped below 1/3 of VCC. Pin 6 is the threshold and turns off the output when the voltage supplied to it reaches above 2/3 VCC. And the discharge, pin 7, when the output voltage is low, it discharges that capacitor to the ground. With Ohm's law, I calculated about 7 milliamps to power my LED. But I can also calculate the rate of the pulses. If I multiply 0.69 times 100 microfarads times 12K resistance, I get the on pulse. So it's on for 1.08 seconds. And then if I multiply 0.69 times 100 microfarads times 5.1K, I get about 0.54 of a second. So what's going on in the astable mode of the 555 timer chip is it's acting as an oscillator and creating a square wave, and that square wave is what's turning the light on and off. Thank you.